Okay, so in this video, we're going to be looking at how can we solve exponential equations using logarithms. Just like anytime we're solving, we are going to be using this idea of StatMap. So this is just your order of operations backwards, and this is how we can go about isolating a variable. So the first thing we always want to ask is simply, is there anything we could add or subtract to the other side? So for this first one, I see really quickly, we can add 5 to the other side, and that gives us 18 here. Once we've done that, we then go to the next step and we say, okay, is there anything we can multiply or divide to the other side? A lot of people want to try and multiply this in here, but that's not our goal. We're not trying to combine things on the side. We're trying to isolate the x. So instead of trying to combine, we're going to go ahead and divide it over to the other side. That leaves me with 2 to the x minus 1 equals 3. Now I can do the same idea for my other one that I have on the page. First thing I'd ask is there anything I could add or subtract? And I don't. I don't have anything other than this right here. So I'm going to then go to multiply and divide. I want to get rid of this 2. I'm going to divide it over. At this point in our solving process, we're now at the e. We're ready to get rid of our exponent. In order to do that, though, we're going to have to try and figure out how do we undo an exponential. And this is the big idea that a logarithm is the inverse of an exponential. So they undo each other. So just like with all of the other steps where we are adding 5 to both sides to undo it, we are dividing by 6 on both sides to undo it, we're going to take the log of both sides to undo it. So what that looks like is taking the log, we're going to take the base of whatever your exponent was, so the base 2 of 2 to the x minus 1 is equal to the log base 2 of 3. Versus for this one here, I would do the same thing and take the log of both sides, but because my base was a 3, I would take the log base 3 of both sides. Now, the purpose was to undo it. Here, adding 5 undid the negative 5. Here, dividing by 6 undid the multiplying by 6. So here, taking the logarithm undoes the exponent, which means this part cancels out, leaving with just x minus 1 equals the log base 2 of 3. Here, it cancels out, leaving me with just 2 to the x minus 1 equals the log base 3 of 27. At this point, I'm going to use the p. We're now done. We're ready to start our order of operations or our solving order of operations over again. We're going to start again asking, can I add or subtract anything to the other side? One of the things that I want to advise against, once you've created your logarithm, it does not change. I'm going to write this in red. Something that I see people often do here would try to write this as the log base 2 of 4, but that's not right. Once you've already created your logarithm, nothing is going to affect it. It is not, when you add this, it's being added to the outside. If we were to divide, it'd be dividing the entire thing. So make sure that once you've created your logarithm, do not change it. So here I have my final answer. You can see that example again on this side. In order to keep getting rid of x, I need to add 1 to the other side. And then I'm going to divide my entire thing by 2. Now, this example does have something slightly different. In this case, log base 2 of 3, that's not a common logarithm that we know how to solve. There isn't a perfect integer exponent that turns 2 into 3. So we would leave our answer as such, unless we had a calculator that we could utilize. Over here, though, we actually do know the log base 3 of 27. We know that that is equal to 3, so we say x equals 3 plus 1 over 3. I'm sorry, those should be 2's. So we get 4 divided by 2, which is equal to 2. So to zoom out, go through our steps again, we're really just following StatMap. We add or subtract anything we have to the other side. We then divide or multiply by any number we can to get it to the other side. And then when we get to the exponent, in order to get rid of our exponent, we take the log of both sides. On the side with the x, that just undoes the exponent, bringing it down. And then on your other side, you actually have a logarithm. Once you've done that step, you're ready to start SAD map over and to actually isolate your x.